So we are now in our third topic, which is urban transportation planning concepts. So, what is planning? So, it has been defined as the process of working out beforehand, scheme, program, or method for the accomplishment of an objective. So, in urban transportation planning, a set of alternative transport plan is then generated for that of the year. These plans incorporate varied nature and amount of transport facilities. The operating characteristics of each alternative in the year are then estimated in the form of flows on each link of the year networks. So, in urban transportation planning, there are factors to be considered. First is the mobility. What mode of transport? Second, infrastructure. Third, services. Fourth, cost. And last is regulations. Going with modes, there are different modes of transportation. We've been talking about that in our previous topics. We've got air transport, land transport, water transport, railway. The second factor would be the infrastructure. Example of this is your roads, your terminals, your ports, bike lanes, those kinds of infrastructures. The third one would be services. Um, you've got your, and a good example for that is your railway. You've got BIP cards, how to do that. There are certain companies offering, private companies offering services for transportation. Your freights, your packages, that's one kind of services. The fourth one is the cost. What is that? Um, to build infrastructure, you need money. So where do your taxes go? So that's one thing. Fuel, buy fuel, toll gates, fare, that's part of the cost. And lastly is regulations. How are we going to regulate the system? Certain routes, certain assignments, um, signages. You also include their safety, traffic safety. That's one thing to be considered. So the usual criterion for choice among the alternatives is that the difference between the collective benefits to users in the form of reduced travel impedance and the money costs of constructing and maintaining this facility should be a maximum. So there are a lot of factors to be considered. Those five are the main ones. So let's go to urban transportation planning. What does it really mean? So there are three, starting first. Understand how decisions to build transportation facilities are made, understand basic elements of the transportation planning process, and lastly, understand basic elements of travel forecasting. So there are common types of urban land uses. To tackle this before, I'll just um, give it a review. So there are residential, commercial, industrial, institutional, recreational, and agricultural. So this can be found based on your CLUP, your Comprehensive Land Use Program. So this varies depending on the municipality or city here in the Philippines. But it's also the same in other countries. So going back to our basic elements of transportation planning, again, the situation definition, problem definition, search for solution, analysis of performance, evaluation of alternative, choice of project, specification, and construction. I know we have tackled this before and I have given you few examples, but I'll give you another one for the sake of urban planning. So, example, planning the relocation of a rural road, simple yet good enough to explain the steps. So, basic one. Step one, situation definition. So, to understand the situation that gave rise to the perceived need for the transportation improvement. So, this one, they are highlighting this. It's the urban area. Step two, problem definition. So, purpose of the step is to describe the problem in terms of the objectives to be accomplished and translate those objectives into criteria. What are those objectives? Statements of purpose, reduce traffic congestion, improve safety, maximize net highway, and it user benefits. What is criteria? This one is the measures of effectiveness. You consider the travel time, accident rate, the delays. The third step would be search for solutions. So here, they have other alternatives. Either this one, extend it this one, or have this one. So, fourth step would be the analysis of the performance. So, those are our options. Now we analyze our options. So, it's to estimate how each of the proposed alternatives would perform under present and future conditions. So, here is a table they considered. So, they have the speed, the distance, the travel time, the accident factor, construction cost. Yun, very important. Reduce displaced into city traffic, present, future returns in 20 years, air quality, noise, tax laws, trees to be removed. That's also one consideration. And of course, the runoff. So we have one, two, three, four, five options here. So they have here. So number of residents to be displaced. For example, here sa 2, sa alternative number 2, there are 7 residents to be displaced. 3 for option 3 and 0 for option 4. So this is one factor. The speed here, 55 miles per hour. That's fast. The distance, you can see this is the shortest. Alternative number 1, which is 3.2. Travel time, shorter. The alternatives 2 and 3 are the longest. Accident factor, 1.2, 3.5, 2.5. This one, 4. A higher accident factor. The construction cost, I have 0 for this one. This one's 1.5, 1.58, 1.13, and 1.54. So there are a lot of options here. You can just see, and this is used to analyze the performance of our options. Step number 5, ranking of alternatives. So here, they have ranked this one. For step number 6, we have the evaluation again of our alternatives. The travel time between West Harrington and US 1 versus cost. This one, the cost and the travel time. So options 1, 4, 2, 3. Here, 2, expensive. Existing condition would be your 0. So you only have 4 options. This one in terms of accident factor and the cost. So 2, high risk. 3 is below. So the next step would be the choice of the project. So based on the alternative evaluation in step 5, we will choose the best alternative for design and eventually construction. The best choice may not be built because of oppositions by the people of the community that is affected. So if you can observe, most of it, most of the checking that we had, we the alternative number 3 is the best option. But there are 3 residents to be displaced. In the last step would be the specification and construction. Once the project has been chosen, a detailed design phase is begun in which each of the components of the facility is specified. Though there are 3 residents to be displaced and other things needed to be considered, that is actually can be of help in during the planning, creating the pre-planning stage, before we proceed to the construction. Same here in the Philippines. We do that. We have a certain section in the planning division um, that caters right of way issues, those people who are going to be affected, their lot. And we also have what we called the issuance of ECC under the EMB of the DENR. Before we construct certain infrastructure, we have to secure that certificate to make sure that the environment is not compromised or it will not be affected or deteriorated because of that project. So that's it. That's one consideration. Now let's proceed to system and environment. So what is a system? A system may define as a set of components that is organized in such a manner as to direct the action of the system under inputs towards specific goals and objectives. So again, same thing with our transportation planning. You need your objectives and criteria before we create a system. What about environment? An environment may be defined as to set of all components outside a system which both influences the behavior of the system and which in turn is influenced by the behavior of the system. So here are your system. All modes of urban transportation. We have the bus, transit, taxi, passenger car, etc. So we can classify them as follows. So urban passenger transportation system, urban public transportation system, urban goods transport system, urban intermediate public transport system, urban personal transport system. So the urban transportation system may be thought as corresponding to social and economic forces that exist in urban areas. This urban socio-economic environment is in turn influenced by the characteristics of the transport system. So here are those classifications. Passenger transportation system, public transportation system, your goods transportation system, intermediate public transport system, and personal transport system. So who does all these things? A system planner. So what is the role of the system planner? They are the ones who conceived in general ways as the direction of her efforts to design a system that achieves maximum integration or degree of fit between the system and its environment. So let's have an example for that. Example, maximize mobility of people and goods. So what are the objectives? We have to minimize travel time. The second one, minimize travel cost. Third, provide adequate frequency of service. Fourth, provide adequate system capacity, provide adequate system safety, and lastly, provide adequate system reliability. So, what will be our standards? We already have our objectives, criteria. Now, how are we going to maximize mobility of people and goods? First one, to minimize travel time. Then, the travel time by public transport between major activity centers not exceeds 30 minutes. The second one, minimize travel cost. The travel time cost by public transport not to exceed 15% of travel cost of private transport. Third one, provide adequate frequency of service. The frequency of public transport service on any route to be not less than 3 per hour. Fourth, provide adequate system capacity. The peak hour occupancy of public transport vehicles not exceed the permissible limits. Fifth, provide adequate system safety. Fatal accidents involving public transport vehicles to be less than 1% of the total. And lastly, provide adequate system reliability. At least 95% of public transport operation to be as per the published time schedule. So these are the standards that the planner should use to obtain this goal. Moving to our next topic, definition of study area. So in our case, our study area is an urban area. So how do we consider an urban area. First, if the population is not less than 5,000. Second, non-agricultural workers, not less than 75% of the total workers. And third, population density not less than 400 per square meter. So this is the towns with population of 0.1 million and above are termed as cities. So here, if you can observe, this one is the zone centroid, the center of the zone. This is your zone. This one is the urban area boundary. This one. And this one is land use parcel or your traffic zone. That's how you create. So let's go to the transportation survey. So the first stage in the formulation of a transportation plan is to collect data on all factors are likely to influence your travel pattern. The work involves a number of surveys as to have number 1, an inventory of existing travel pattern. Number 2, an inventory of existing transport facilities. Number 3, an inventory of existing land use and economic activities. If you can go back a while ago, we have the options 0, 1, 2, 3, and 4. So 0 was actually the existing. So the study area for which transportation facilities are being planned is first of all defined. So transportation planning can be the at the national level, the regional level, or at the urban area level. For planning at the urban level, the study area should embrace the whole contribution containing the existing and potential continuously built up areas of the city. The imaginary line representing the boundary of the study area is termed as the external cordon line. The area inside the external cordon line determines the travel pattern to a large extent, and as such, it is surveyed in great detail. The land use pattern and economic activities are studied intensively, and detailed surveys, such as the home interview, are conducted in this area to determine the travel characteristics. In the other hand, the area outside the cordon line is not studied in such detail. So how do you select cordon line? I mean external cordon line. So the selection of the external cordon line for urban transportation planning should be done carefully with due to consideration of the following factors. What are those factors? Number 1, the external cordon line should circumscribe all areas which are already built up and those areas which are considered likely to be developed during the planning period. The external cordon line should contain all areas of systematic daily life of the people oriented towards the city center and should in effect be commuter shed. Be the commuter shed. The third one, the external cordon line should be continuous and uniform in its course so that movements cross it only once. The line should intersect roads where it is safe and convenient for carrying out traffic survey. And lastly, the external cordon line should be compatible with the previous studies of the area studies planned for the future. So here is an example. So this is an example of roads, and this is your external cordon line, or this one. So let's go to zoning. So the defined study area is subdivided into smaller areas called zones or traffic zones. So the purpose of such a subdivision is to facilitate the spatial quantification of land use and economic factors which influence travel pattern. Subdivision into zones further helps in geographically associating the origins and destinations of travel. Zones within the study area are called internal zones, and those outside the study area are called external internal zones. In large study group projects, it is convenient to divide the study area into sectors, which are subdivided into zones. Zones can themselves be subdivided into subzones, depending upon the type of land use. A convenient system of coding of zones will be useful for the study. One such system is divided the study area into 9 sectors. So the example that I'm gonna be presenting. So the central sector or the CBD, what does CBD means? A central business district. This is the commercial center of an urban area. Usually, CBD is designated as 0, and the remaining 8 are designated from 1 to 8 in clockwise manner. The prefix 9 is reserved for the external zones. Each sector is subdivided into 10 zones bearing numbers from 0 to 9. So that's how you do it. So here is an example. This is actually based in the US. So here, the Charlotte Area Transportation Study, Thorough System, and Zone Boundary. So they have one, two, three. So this is their zones, traffic zones. So it would be helpful if the following points are kept in view when dividing the area into zones. So the zones should have a homogeneous land use so as to reflect accurately the associated trip making behavior. So you will understand this further when we go to our traffic demand models. So if you remember the trip distribution, trip generation, modal split, and route assignments. So yes, you will be discussing that in the next topic. So moving on, number two, anticipated change in land use should be considered when subdividing the study area into zones. Three, it should be advantageous. It would be advantageous if the subdivision follows closely that adopted by other bodies, for example, census department. For data collection, this will facilitate correlation of the data. So census, we already have that. Number four, the zones should not too large to cause considerable errors in data. At the same time, they should not be too small either to cause difficulty in handling and analyzing the data. As a general guide, a population of 1,000 to 3,000 may be the optimum for a small area, and a population of 5,000 to 10,000 may be the optimum for large urban areas. In residential areas, the zones may accommodate roughly 1,000 households. Proceeding. Number five, the zones should preferably have a regular geometric form for easy determining the centroid, which represents the origin and destination of travel for your OD study. Number six, the sectors should represent the catchment of trips generated on a primary route. Number seven, zones should be compatible with screen lines and cordon lines. Zone boundaries should preferably be watersheds of trip making. Number nine, natural or physical barriers such as canals, rivers, or any type of um, water bodies can be form convenient zone boundaries. And lastly, number 10, in addition to the external cordon lines, there may be a number of internal cordon lines arranged as concentric rings to check the accuracy of survey data. So what is a screen line? It is mentioned here. We already discussed about the cordon lines. Now let's proceed to the screen lines. So running through the study area are also established to check the accuracy of data collected from home interview survey. Screen lines can be conveniently located along physical or natural barriers having a few crossing points. And examples of such barriers are your rivers, railway lines, canals, etc. So these are the types of movements. For large urban areas, the internal or internal travel is heavy, whereas for small areas having a small population less than 5,000, the internal to internal travel is relatively less. Most details of internal to internal travel can be obtained by home interview survey. So what are these external, internal, internal to internal? So these are the basic movements for which survey data are required. So let's have the internal to internal. So when you see this arrow, this one's the origin, destination. Origin, destination. So this is an internal within your zone or your boundary. The second one is external to internal. Where is that? It's this one, from external to internal, going inside your zone. The third one is your internal to external. So from outside your zone going inside your zone going outside your zone. So that is an internal to external. And we also have the external to external. So they're just passing by. This one, the long ones. So the details of internal external, external internal, and external internal travels can be studied by cordon surveys. So let's go to data collection. When collected at home, the data can be wide ranging and can overall the trips made during a given period. The data collected during the trip is necessary of limited scope since the procedure yields data only on the particular trip intercepted. So that is the data collected at home. There's also the data collected during the trip end and also a data at the destination of the trip. So at the destination end, the direct interview types of surveys provide data on demand for parking facilities and or the trip ends at major traffic attraction centers such as factories, offices, and commercial establishments. The following are the surveys that are usually carried out. So there is a home interview survey, commercial vehicle survey, intermediate public transport surveys, public transport surveys, roadside interview surveys, postcard questionnaire surveys, registration number surveys, and lastly, tag on vehicle surveys. The information to be collected from home interview survey can be broadly classified into two groups. You have the household information, and number two would be the journey or the trip data. So this one is mostly about socioeconomic profiling. So the household information that you need contains the following data. We have letter A, size of household. Letter B, age of all the members of the households. C, sex. D, structure of households. E, employee. F, occupation. G, place of work. H, number of vehicles owned. And lastly, household income. So this is for your home interview. Journey data will contain information all trips made during the previous 24 hours with regards to number one, your OD survey or your origin and destination of trip. Second is the purpose of trip. Third, modes of travel. Fourth is the time of start of trip and time at finish of trip. So mostly your time of travel. The inventory of existing transport facilities should be undertaken to identify the deficiencies in the present system and the extent to which they need to be improved. So, how are you going to do that? You have to have the inventory of transport facilities. So, the inventory consists of inventory of streets forming the transport network. So, there is what we call the link or the width, length, and the number of lanes. If you can observe here in our locality, we are trying to have 4 lanes for our national highways. That's one called the link. So in every for a national highway, you have a 3.35 meters and a span of 4.5. That's how you that's the standard length for a national road. Then, of course, in your transport network, there is also what we call nodes. So the nodes is complete geometric of intersections. So that's how you create your transport network, junctions. Second, traffic volume composition, peak and off-peak. So yun, meron yan sa peak hours. Studies on travel time by different modes. You already know the different modes of transportation. So you have to know the travel time. For example, if it's by car or by public buses, or if you're gonna ride a bicycle, those are different modes. You have to consider the travel time. You actually have that now. If you're going to use your Google Maps, they'll give you options where to go. Lesser traffic, they give you um, the travel time, the options of what mode you're going to use. That's they're doing that now. The next one would be the inventory of public transport buses. And the second would be the inventory of rail transport facilities. You also have your parking inventory, and lastly, your accident data. Aside from the transport facilities, you should also have the inventory of land use and economic activities. So, number one, the inventory of land use. Since travel characteristics are closely related to the land use pattern, it is of utmost importance that an accurate inventory of land use be prepared. So, data on intensity of usage of land for different purposes, such as residential, industrial, commercial, recreational, open space, etc., in each of the traffic zones, are to be located from concerned departments or organizations. Meanwhile, number two, the inventory of economic activities. Aggregate data on demographic and socioeconomic activities should be collected other sources to include the following. First, the population of the planning area in various zones, age, sex, and composition of the family, employment statistics, housing statistics, income, vehicle ownership. Next topic would be our transport related land use model. So the land use transport interaction. First, land development generates travel and travel generates the need for new facilities, which in turn increase accessibility and attracts further development. Number two, the question of whether transportation influences land use or the development or whether land use dictates transportation has been a matter of ongoing concern among transportation professionals. Third, thus, the connection between transportation and land use is a fundamental concept which needs to be understood clearly. In transportation planning, as transportation and land use are inexorably connected. Definitely. Fourth, everything that happens to land use has transportation implications, and every transportation action affects land use. Number five, transportation's most significant impact on land use development, and more development generates additional travel. Increased access to land raises its potential for development, and more development generates additional travel. Number seven, one access has been provided, land patterns begin to change over a period of time. The results of these changes are, for the most part, irreversible. So, land use is very important in terms of transportation planning. So, the land use transport feedback cycle here. In a transport system, you should know the activities. From the activities, you know the land use. From the land use, then you can have the accessibility, the roads or other infrastructures, then you can create your transport system. It's a cycle. As what number seven has said, again, it's irreversible once there are changes. So, a variety of land use transport models have been developed in the past 15 years. So, a few of them are research models having excellent capabilities for sensitive forecasting, while some are operational models. The former group of models require extensive data collected through special surveys, whereas the latter need data which are collected routinely by planning departments. The lower derivative models fall into the latter group and are very popular. So who are these planning departments? We have our DPWH. They are the ones who do the survey. Again, I mentioned before the automated traffic count, like the machine that they have. They have that one where they pass along the road. Those two black ropes. That's what they use to collect traffic counts. So, the selection of land use transport model. While selecting the model, a number of considerations become important. These are number one, simplicity. The model should have a simple casual structure, which should be easy to comprehend. A simple model will generally consume less of time and resources. Number two, modest data requirements. Requirements must be modest. In fact, some of the good models make use of data routinely available with the planning department. Number three, adaptability. The model should be adaptable to any given location. Number four, comprehensiveness. The model should be comprehensive and should synthesis the relationship between activities, housing, and transportation adequately well. Number five, operationally and rapidity. The model should be operational, capable of easy interpretation, and should be able to test rapidly a wide range of policy options. And lastly, computer cost. The model should be operational at a relatively cheap computer cost. So there is what we call the Lowry derivative model. So the Lowry derivative models have many of the above attributes. As what it was said a while ago, it is the latter option. So they are simple to use, require modest data, are comprehensive and economical, have good response to change in input variables, and have simple causal structure. They have therefore been used extensively and successfully in a number of studies. So here is the fundamental structure of the model. It is illustrated in this figure. First, the exogenous allocation of basic employment, employment at home allocation function, endogenous allocation of households, population serving employment allocation function, check constraints on population and service employment, under which there are total employment vector, which is the household vector, and the work home trip vector, which is home service trip vector. So this is the structure of your Lowry model. So going to our Lowry derivative model, the Lowry model relates the three principal components of the urban area. First, your population, second, employment, and third, communication between population and employment. So the model equation system. So the Lowry model can be represented in terms of nine simultaneous equation and three inequalities. The following notation will be used. A is denoted as the area of land, E for employment or the number of persons, N population or the number of households, T index of trip distribution, and Z your constraints. So for the land use, the total land available in each zone and the land therein not usable by any of three activities are given thus. AJ is equal to AJU plus AJBJ plus ARJ plus AHJ. So on and so forth. So the basic sector for each zone, the land by basic establishments, which is denoted by ABJ, and the employment opportunities provided by these establishments, which is EBJ, are exogenously specified. So continuing, let's proceed to the retail sector, where the retail sectors are divided into groups, each having its own characteristics production function. The employment in each of the retail sector can be considered roughly to be a function of the households in the region. So the equation we have is E of k is equal to a raised to k times n. The distribution of this retail employment among the zones depend upon the market at each location. If the shopping trips originated either from home to from workplaces, the market potential of any given location can be defined as weighted index of the number of households in the surrounding areas and the number of persons employed nearby. Thus, E raised to kj is equal to B raised to k um, multiplied by the summation of C raised to k ni over T raised to k ij plus D raised to k ej um, from the limits of n where I is equal to 1. So C raised to k and D raised to k are measures of the relative importance of homes and workplace as origin for a particular type of shopping. B raised to k is a scale factor which adjusts retail employment. So the equation for that is E raised to k is equivalent to the summation of E raised to kj raised to n over j is equal to Proceeding. So the total employment is equivalent to the above procedure determines the amount of employment in any zone for each category of retail trade. The sum of these employment figures plus the quantity of basic employment allocated to the zone is the total employment for the zone. Thus, E sub j is equal to E sub j raised to b summation of E raised to kj from M equals to K equals to 1. Household sector, the region's population of household is a function of total employment. Thus, N is equal to F. This is the equation. So, same household sector, the region's population of household is a function of the total employment. Thus, having this equation. The population living in the zone J is also a function of the employment opportunities in the different zones and the different measures of accessibility from zone J to each of those zones. Thus, you have this equation. So the sum of zone population must equal to the total population of the region. N is equal to the summation of N, J raised to N equals to I equals to 1. Meanwhile, the constraints, in order to limit the dispersion of retail employment, minimum size constraints Z raised to K is imposed, expressed in terms of employment. If the market potential of the particular location does not justify an establishment above this minimum size, the customers are sent elsewhere. Thus, you have this equation or this equation. So, in order to prevent the system from generating excessive population densities in locations with high accessibility indices, a maximum density constraint is imposed. So the value of this constraint, or the number of household per unit area or residential space, may vary from Z1 to the case under zoning ordinances. So you also consider this one. And lastly, the amount of land set aside of retail establishments must not exceed the amount available. So you have this um, equation to be considered for your constraints. This constraint also prevents the assignment of negative value of the residential area. So that was our Lowry equation. Meanwhile, we also have another equation for which is about the Hansen accessibility model. So this one is designed to predict the location of population based on the premises that employment is the predominant factor in determining location. So he suggested the use of an accessibility index, which is denoted by IJ. I's of j. So the equation is, we have this, is equivalent to E's of j over D's of ij times b. So here are um, the legends for that one. So A's of I's of j is equal to the accessibility index of zone I with respect to zone j. E's of j is the total employment. D's of ij is the distance between I and j, and b is an exponent. So the overall accessibility index for zone I is therefore this one. So the amount of vacant land that is suitable and available for residential use is also an additional factor in attracting future population to the zone in question. This is referred to as holding capacity H of I. The development potential of a zone D sub I is therefore D sub I is equal to A sub I H of I. And the population is distributed to zones based on the relative development potential, which is A sub I H of I over summation of H of I and H of I. So, if the total growth factor in population in a future year is G sub t, the population allocated to zone I will be G sub I is equal to G sub t, quantity A sub I, A sub I, H of I over summation of H of I, H of I equivalent to G sub t, quantity D sub I divided by the summation of D sub I. Going to our next one would be the density saturation gradient method. So this density saturation gradient method was first used in Chicago Area Transportation Studies, or CATS. Since then, many researchers have elaborated on this basic work. So there are three empirical rules used in this method. Number one, the intensity of land use declines as the distance or travel time to the CBD increases. The ratio of the amount of land in use to the amount of available land decreases as distance from the CBD. The proportion of land devoted to each type of land use in an area remains stable. So Clark made another assumption that is not dealt with the density equation. He assumed that the higher downtown densities and the lower suburban densities will tend to equalize over time in most urban areas. This is supported by the findings of the most recent census, which indicates strong trends of population decline in the CBD and increased population movement toward peripheral and suburban areas. This observation implies that the density saturation gradient is a function of age or original location of the city and can be determined experimentally. So here is the equation. So Clark derived the basic equation for expressing this density distance relationship. So this one. So d of x, the population density at distance x from the city center. So d of 0 is equal to the central density as extrapolated into the CBD of the city. If you can remember, we denote it as 0. And b is equal to the density gradient or slope factor, and e is based on natural logarithms. So holding capacity is given by the following expression. So you have this equation where H of C sub I is the holding capacity of zone I, P sub I existing residential population of zone, while the V sub I is the vacant, available, and suitable land in zone I, and D is the anticipated average density at which all future residence development will occur. Also, percentage population saturation of zone I in a certain year is equivalent to the population of zone I in a certain year per holding capacity of zone I times 100. The general procedure can be described as follows. So, step one, establish the relationship between residential density and the distance from the CBD. Step two, determine the percent population saturation for each zone and aggregate this percentage by ring and sector. Number three, determine the percentage area of useful available land in each zone that has been earmarked for residential use. This percentage, known as the percentage residential saturation, is plotted against distance from the CBD. So there are 7 steps. On step 4, obtain the total population for forecast year for the city. This figure is determined exogenously. Step 5, plot a curve representing the residential density, similar to the one plotted under step 2, such that the area under the curve is proportional to the total population obtained in step 4. In step 6, forecast population totals by analysis rings. These totals are determined by scaling off appropriate ordinate values from the horizon year curve. And last step for this density saturation gradient method is that you distribute ring totals to individual zones by subjectively weighing each individual zone's attractiveness according to such factors as distance to shopping centers, distance to major street systems or bus lines, residential capacity, nearness to school, and so on. So that is about how we do urban planning. But we will be doing problem solving in the next topic, which is about our trip travel demand models, which is your trip generation, trip distribution, modal split, and your route assignment. So that is for our topic number 3.